All right, guys, another quick video today. This one goes with homework 24, which is all about something called dilations. Okay, dilations, and we're going to throw in scale factors with that. Now, what a dilation is, you've got this big, complicated diagram that your textbook on Math Excel is going to give to you. But basically, what a dilation is if I take some shape, like this little triangle right here, this PQR triangle, if I take that shape and I multiply that shape, if I double the sides, so if I take this length right here and times it by 2, and this length times it by 2, and this length and times it by 2, then what I end up with is this bigger triangle over here on the right. And this big one on the right, if you notice, it took this P, and the new triangle it's the same letter, but it puts that little symbol up there. It almost looks like, what's that called in language arts, an apostrophe. In math, we usually call that prime. So basically what we're doing is we're taking shapes and we're either shrinking them or blowing them up. But what we don't want the proportions to change. Okay, so in other words, if I have, let's say I start with this square, and right now my lengths of my sides are 2, and I want to make a bigger square. So we'll call this little a, little b, little c, little d. And if I want to make a bigger square, let's say I want to dilate this by a factor of 3. I want to make a square 3 times with a factor of 3. I got to be careful how I word that, because if I say it the wrong way, it comes out way wrong. So what that means is instead of a length of 2, I'm going to have a length of 6 on all of my sides. And my sides, this corner is going to become A prime, B prime, C prime, and D prime, because they come from those original corners of my original shape. So we just put that little tick mark after to tell us, hey, that's the new shape. Here's where it came from, okay? So what we are most interested in with these dilations is what's called the scale factor. And the scale factor tells me, what did I do to the small image to create the big image? All right, now the reason I caught myself, this square right here is not 3 times as big as this square, okay? The scale factor is 3. My scale factor is 3. So I multiplied everything by 3 to get the bigger one, but it's not 3 times as big. In fact, this square right here has an area of 4. This square has an area of 36. So I didn't make my square 3 times bigger. I actually made my square, 8 times bigger? So we've got to be careful with our wording. What we're going to say is it has a scale factor of 3, not that it's 3 times as big, okay? It has a scale factor of 3. So a lot of what you're going to be doing on the work today is trying to figure out what the scale factor is. So here's a couple of examples. If I have this, we're going to skip this box right here, and we're going to go right to number 1. So if I zoom in on number 1 right here, it tells me that the red figure is a dilation image of the blue figure. So what that means is the blue is my original, and the red is my new figure. And it wants to know, did it get bigger or smaller? Was it an enlargement or a reduction? And then it wants me to find the scale factor. Well, hopefully you can tell that the shape got smaller, right? If the red is the new one, then this was definitely a reduction. My shape got smaller. The second part of the question is, what is my scale factor? What was my scale factor used to get from the big one to the small one? Or in other words, what did I multiply by to get my big image to turn into my small image? And here is all you have to do, and this is one of the benefits of watching the video and not trying to use that get help button on everything. All you have to do is take one side of the new shape and measure it and put that over the same side of the old shape when you measure it. Okay, that's all you have to do to get the scale factor. So my new shape, this red one right here, let's measure the bottom. So from this to this, that's length 2. My old shape, 1, 2, 3, 4, 5, 6. 2 over 6 simplifies to 1/3. So my scale factor is 1/3. Now where you have to be careful is don't measure the right side of the little shape and then the top of the big shape. You have to measure the same piece of each shape. As long as you do that, you just put the new piece over the old piece, and that gives you the scale factor, all right? So number 2, the red is the new one. My red is new. So that means, and again, hopefully you can at least figure out this part. That means it's an enlargement, right? My shape got bigger. So now what I want is my scale factor. Okay, so I measure any part of the new shape. Now, this one has a few options. You could measure this length right here, which is not going to go very well. That's not an easy measurement to make because you're going to have to use the Pythagorean theorem, and who wants to do that? I would measure something simple like this line across the bottom. Okay, that line across the bottom, that straight line right there, is 3 wide on my new shape. Now that same line on my old shape right here, that same line is only 2 wide. So I put that on the bottom. New over old gives you the scale factor. So my scale factor is 3/2. So that's saying that you multiplied basically by 1.5 to get the new one. That does not mean it's 1.5 times bigger. That means you multiplied with a scale factor of 1.5. And I'm going to keep saying that because I know you're going to want to use those words and I'm going to know what you mean, but it's really important that you understand the difference, okay? The new shape is not twice as big or 3/2 as big. The sides are 3/2 as long, but the shape itself is not 3/2 as big, okay? There's a difference between wording those two statements. Okay, so let's look at a couple other problems using the same idea, okay? It says the image of an ant is 7 times, so the image of an ant is 7 times the ant's actual size, and it has a length of 1.4 centimeters. So that's kind of a little bit of a tricky sentence. So it's telling me that the image is 7 times the actual. So it's telling me my image is equal to 7 times the actual. And it has a length of 1.4. Now, when I read that has a length, it's still talking about the image. So my image is 1.4 centimeters. And that's equal to 7 multiplied by the actual length. So what this problem is asking is, what is the actual size of the ant? Like, how long is the actual ant? It's not 1.4 centimeters. I know that seems really small, but 1.4 centimeters, that's a pretty big ant. So to find the actual size, well, I've already got an equation set up, right? My image is equal to 7 times the actual. So all I have to do is divide by 7. So 1.4 divided by 7, and I ran out of space right here because I'm writing so big. 1.4 divided by 7 is going to be 0.2 centimeters, and that's going to be the actual size of the ant. It's going to be about 1/5 of a centimeter, 0.2 centimeters. Now, setting up these proportions, these ratios here, what you are always going to end up with is this kind of formula right here. the image is going to equal some number that's my scale multiplied by the original, or what do they call it here? The actual object, okay? The image is going to equal some scale factor. Maybe we should put factor right there. Some scale factor multiplied by the actual, okay? So looking at number 6, the image of a capital letter N is 6 times the letter's actual size. And it has a height of 1.68. So the image is 1.68 tall, and that's equal to my scale factor. It's 6 times the size. So 6 times my actual, which is what I'm looking for. So when I do my railroad tracks, I just divide by 6, and you're going to end up with, let's see, 168 is going to be, that's going to go in 20 times, and then it's going to go in another 48. So 28, so 0.28. Sounds about right. Centimeters would be the actual height of the letter, okay? So your image is the scale factor times the actual. Sometimes it'll give you the actual and it'll want you to find the image, which I think we're going to do next, okay? Yeah. All right, so this says number 7. We've got 4 examples right here, and we'll go kind of quick. The red figure is a dilation image of the blue figure with the center of dilation C. Is it an enlargement or a reduction? Well, first of all, the red one is bigger than the blue one, so it's definitely an enlargement. And it wants to know, what is the scale factor? Well, I look at this side, and it tells me that that's 8. And I look at this side, and that's 12. Well, the 12 is the new. Remember, I want new over old. So 12 over 8, and that becomes, when you simplify, 12 over 8 becomes what? 3/2 again. So it's 1.5 times as big. The scale factor is 1.5. The sides are 1.5 times as long. The image itself is going to be bigger than that. Find the image of each point. Now, this one on the homework last year kind of got everybody stuck for a minute because they weren't sure what these numbers meant. Words are hard, guys. So D means dilation, okay? This little number 2 is my scale. And this right here is just a point. So it's telling me I want to dilate with a scale factor of 2, the point 1.5. So on my diagram, if I have a point 1, -5, it wants me to dilate that with a scale factor of 2. So that means I'm going to times both of those points by 2. So I'm going to take 2, times it by 1, and I end up with 2. And then I'm going to take 2, times it by -5, and I end up with -10. You just multiply both points by that scale factor. So it's telling you to dilate what to multiply by, and it gives you the point that it wants you to multiply. So my new point would be 2, -10. So it's going to be over 2, and it's going to be down -10. So it's going to be down here. So I keep that pattern. Dilate with a factor of 1/2, 0, and 6. So my new point is going to be 1/2 times 0 and 1/2 times 6, which is really easy because 1/2 times 0 is 0. 1/2 times 6 is 3. Number 10, dilate with a factor of 10. I like this question. 0, 0. That just means times both of those by 0. So I end up with 0, 0. My point doesn't change at all because my point was 0, 0. All right, what else does it have for you? That's actually it for this homework. So go ahead and work on homework number 24. I think you can handle most of the problems. You're going to have 3 or 4 that involve this kind of form of dilations. You're going to have 3 or 4 that you just have to find the scale factor, and then you'll have a couple that might challenge you just a little bit and ask you to use this in a few other ways.